Um, so this week we're going to start off talking about linear relations. When we call anything linear, we're really dealing with lines, right? Things that graph in straight lines, equations of straight lines. And you guys have dealt with this before. You've worked with it in Algebra 1, but we've got to start off with this before we move into the other stuff because, it's been a while since you've seen it. So as you can see up here, we've got linear relations. When points on a graph lie along a straight line, it's called a linear relation. Basically, anything that graphs in a straight line is linear. And linear relations can be represented by an equation. For example, the equation of this graph can be written as x plus y equals 8. Now, what I want you to think about in terms of lines is notice that the powers of these problems are all 1, right? We don't have anything raised to a square or a cube. Linear relations are always in the first power. Often you'll see them written in the standard form. And I know you guys are really familiar with y equals mx plus b, and we're going to get to that because it's a really important form. But the standard form actually of a linear relation is ax plus by equals c. And there's a couple important things to remember here. One, that a, b, and c are integers, right, which are whole numbers, positive or negative for the most part. But in the standard form of a linear equation, a has to be greater than or equal to 1, right? It can't lead with a negative. Otherwise, we'd have to divide it out. B or C could be negative, but A has to be positive. So, for example, if I have negative 5x plus 6y equals negative 12, to write that in standard form, I would have to get rid of this negative on the 5. And I can do that by dividing everything by negative 1, right? Or multiplying everything by negative 1, it would have the same effect. And this would yield 5x plus 6, oops, my bad, 5x minus 6y equals 12. Now, this is a perfectly legitimate form of the standard, right? It only says that a has to be greater than or equal to 1. So if your x coefficient, if whatever is on your x is negative, you need to get rid of that negative. More often than not, we're not going to deal with things in the standard form. We like this next form a whole lot better as far as what we can work with. And you guys should be pretty familiar with this. It's what we call the slope-intercept form of the equation. And often, you guys will hear it all the time, y equals mx plus b. Or in function notation, you would see it as f of x equals mx plus b, right? Where m is the slope and b is the y-intercept, which is why we call it slope-intercept, right? Because it gives us a slope and it gives us an intercept. And once we have one point on the graph of a line, we can find infinite points on that graph. Now it says slope is the constant rate of change between the points, your rise over your run. There are, sorry, my hand is numb. There are 4 types of slopes. We've got a positive slope, right? Is really just This is a terrible drawing of a graph, right? Positive slope goes up from left to right, right? Then we've got a negative slope, negative. Positive slope goes up from left to right. You could imagine that a negative slope would go down from left to right, correct? Then we have a zero slope. Ooh, terrible graph. A zero slope is a straight line. Let's see if I can draw that straight, right? Right, a straight horizontal line. Notice there's no tilt to it at all, right? It's just straight across, so it doesn't slope. If you guys think in terms of skateboarding or ramps or anything like that, a slope is just that rate of change. How fast does it go? A higher rate of change, right? You're going to have a steady drop. The less you decrease that rate of change, the more you decrease that rate of change, the less steep your slope is going to be, right? Like if you're building a ramp for a wheelchair, you don't want it to have the same slope as the ramp for, say, your skateboard. And then we have an undefined slope. Oops, I didn't change the color this time. Undefined slope, which is a straight vertical line, right? That is dividing by zero. Can't divide by zero, it's undefined. So in terms of slope, those are your four different options with slope. You can have positive, negative, zero, or undefined. And when we're talking in terms of slopes, let's see, I'm trying to find a nice easy one. Say I have f of x, could be y equals, but I'm going with f of x minus x plus 2. In this case, I'm going to look at it right here. I'm going to go, okay, well, my slope is -1. My y-intercept is 2, right? That means I'm going to have a point at 2 on the y-axis. So if I draw a graph, let's see if I can do something even remotely decent here. I've got 1, 2, 3, 4, 1, 2, 3, 4, right? What I know about this graph is that my y-intercept determines where it's going to cross the y-axis, and that is at 2. My slope is -1, and that is the same as saying -1 over 1. Now, when we're dealing with a negative slope, there's a couple things you need to remember. The main thing being is that one piece has to be negative. It does not matter if I make the numerator negative or the denominator negative, but only one can be negative. So if I make my rise run negative, if I go down 1, right, then I have to go positive for the other one. If I were to go up 1, I would go negative for the other one, if that makes sense. Because if I have a positive over a positive, it becomes, if I have a negative over a negative, it becomes a positive. So you can make either the numerator or the denominator negative, but only one. Don't forget that. And then we can just draw our line through it. This rate of change, look, I missed the dot entirely, but you get the picture. Just make my dot bigger. So notice we have a negative slope on this. It's going down from left to right. And that's because of this negative out in front of our x. Now we talked about our neutral slopes, right? We have the 0 and we have the undefined. Slopes of parallel line. Okay, so let's talk about vertical and horizontal slopes. Write each equation to represent the lines shown on the graph. So if we're looking at 11 right here, and we need to write an equation for this graph, this would be x equals 1, 2, 3, -3. That would be the equation for this line, the graph of this line. If we were looking at a horizontal line and we needed to write the equation for this line, it would be y equals, and we're just up 1, so y equals 1. That is the equation for these lines. When we are dealing with either a vertical line, we're going to have something that is x equals. If we have a horizontal line, we're going to have something that is y equals, or we could write it as f of x equals 1. So anytime you see a straight horizontal or straight vertical line, know that it's either going to be x equals wherever that line is, or y equals wherever that line is, depending on whether or not it's horizontal or vertical. The next thing we want to talk about is parallel versus perpendicular lines. And you guys may remember this from the past, but the slopes of all parallel lines are equal. If two equations have the same slope, those lines will be parallel. The slopes of perpendicular lines, no, that's a whole different story. They are what's called negative or opposite reciprocals. Right? So if I have a slope that is, say, 1, let's call it 2. If I have a slope that's 2, a perpendicular slope, right? The perpendicular slope would be -1/2, right? If I have a slope that is -4/5, its perpendicular slope would be +5/4. Notice we have to change the sign in front and then we flip the fraction, right? Those are important things to remember because it's really easy to tell the difference between a parallel line and a perpendicular line, right? Because if they have the exact same slope, they're going to be parallel. No matter what the rest of the equation is, it's going to be parallel. If we have a perpendicular slope, they're going to be opposite reciprocal, negative reciprocal. So if I want to determine whether two lines are parallel or perpendicular, and I say have 10x plus 5y equals 5, and I have -x equals 2y plus 16. Now, I can't just look at this right now and know. I have to put these in the slope-intercept form so I know what the actual slope is. So I'm going to subtract 10x from both sides because, right, I need it all in terms of y. So that's going to leave me with 5y equals minus 10x plus 5. Right? We're going to divide out the 5 because we just want to know what y equals. And I'm going to be left with y equals minus 2x plus 1, right? 5 goes into -10, -2 times, and 5 goes into 5 one time. So this is in slope-intercept form. So I know right now my slope is -2. So if they're parallel, this one better have a slope of -2 as well. If they are perpendicular, they're going to have opposite slopes, right? So I'm going to start by subtracting 16 from both sides, because I'm trying to isolate that y over here. And I'm going to be left with minus x minus 16 equals 2y. And I'm going to go ahead and I'm going to divide both sides by 2. And I'm going to be left here with minus 1/2 x minus 8 equals y. Now, I can rewrite that the other way. I could write that as y equals minus 1/2 x minus 8. But all I really care about right now is what is in front of my x. Because it's asking, are they parallel, are they perpendicular, or are they neither? And when I look at this, I'm going to want to say that they're perpendicular, right? Because this is the reciprocal of that. But notice they are not opposite, right? This is negative and this is negative, so they cannot be perpendicular. They aren't the same, so they're not parallel. So in this circumstance, we would say they are neither. So there's a little example of how to deal with parallel and perpendicular. The other points we're dealing with are x and y intercepts. And we talked about the y-intercept a second ago when we were graphing the slope-intercept form. But really, x and y-intercepts are just the points where we cross the x or y-axis, where the graph of a line crosses the x-axis. It's called the x-intercept. And where the graph of the line crosses the y-axis, we have the y-intercept. So here is our y-intercept, and here is our x-intercept. They are also referred to as, the x-intercepts are often called things like roots or zeros or solutions. Zeros you'll hear a lot, because when you want to find an x-intercept, you set an equation equal to 0, right? And that should give you anywhere that 0, where the graph of that line is going to cross the x-axis. So you'll hear it as root. You'll hear it as solution. And you will hear it as the 0 to the equation. Now, when you want to find the intercepts, if you're looking for the x-intercept, set y equal to 0 and solve for x. If you're looking for the y-intercept, set x equal to 0 and then solve for y. So we're going to do the example that's provided, right? We have y equals negative 2x plus 5. So if I want to find the x-intercept, right, let's look at the instructions right here. It says if we want to find the x-intercept, set y equal to 0 and solve for x. So we've got minus 2x plus 5 equals 0, right? We just made our y 0. And now we can go ahead and solve. We just get x all by itself. So we've got minus 5 on both sides, which gives us negative 2x equals negative 5. And then we can divide. Let's change colors. We can divide by negative 2 to start working on isolating that x. And that's going to give us x equals negative over negative is a positive. So that's going to give us 5 halves. So our x-intercept, we could just say x equals 5 halves, or we could go in terms of a point, it would be 5 halves 0 if we were graphing it, right? The x-intercept's always going to have a y value of 0 because it's on this line right here where there is no y value. Our y-intercept, we're going to do the opposite, right? We are going to set x equal to 0 and solve for y. So for our y-intercept, we are going to take the same equation. We're going to go Minus 2, well, here's an x, so we're going to put in 0. Plus 5 equals y, right? Negative 2 times 0, just 0. So we wind up with 5 equals y. We can write that if we want as y equals 5, because when they're equal, the sides are interchangeable. If we wanted to write that in terms of a point, it would be 0, 5. And when we graphed that, right, it would be, oh, look, it's already graphed for us up there. Is it 1, 2, 3, 4, 5? Well, it would be a point up there, right? But it's a point on our y-axis. Looks like that is pretty much all I have for you on this one. There'll be a Delta Math assignment to go with it. I'll give you one to do as an Edpuzzle question. But then try and get to your Delta Math shortly after watching this video, because it will really help to kind of sink it in if you do it right away and don't take too long and forget how to do it before you settle in. So that's all I have for you for now. I'll see you in class.